Hey everybody, welcome back to Mr. Murray's Mathland. Mr. Murray here. We are taking a look at a kind of a strange topic in pre-calc to the first time you see it, which is called changing a complex number into trig form or trigonometric form, also sometimes called polar form. And when you learn about polar graphs, you would understand the connection that both have to do with finding r and finding theta. So maybe a little review here that a plus bi, that's what we call the standard form of a complex number. And if you're at this point, you should be very comfortable with that concept. And a plus bi is also sometimes written as x plus yi. And when you graph it on the complex plane, you would understand why that is. But changing it into this form, r cosine of theta plus I sine of theta, that's called trig form. And obviously it's the one that has trig expressions in it. Sometimes in engineering they do enough with this that they'll abbreviate this as r cis theta, r cosine plus I sine of theta as an abbreviation. They do a lot of work with that. But right now let's just talk about how to change things from standard form into trig form. So our first example here is 6 root 3 minus 6i. And we're going to approach these as if we have no calculator for the first two examples. The third one is going to require a calculator, so if you're in the market for that, hang on or fast forward to that one. So first, 6 root 3 minus 6i. And the reason why this is also written as x plus yi is because that tells you how to graph it essentially. That you're thinking of on the complex plane. Instead of the x-axis, we have the a-axis, the real axis, and y is the b-axis, the imaginary coefficient. And so this is really just saying plot a point that's 6 root 3 comma negative 6. That's that y value, the b value there. So I'm going to plot that point. So that would be, doesn't have to be to scale or anything, but I'm going to roughly draw 6 root 3 to the right and down 6. So, over a lot and down a little, right? So that would be putting this point, 6 root 3 negative 6 would be, right around there, just ballparking it. That's that point. And I'm going to talk two ways to get this. And it's up to you which way you like. One is from a very geometric standpoint, and in pre-calc we do so much with special right triangles and geometry that this is often the easiest way for a lot of kids. So here's the idea. You think of that triangle, and what did I just do? I went 6 root 3 to the right, so that's a leg of 6 root 3, and then I went straight down, so that's a right angle. I went down 6, or you could call that leg negative 6 because you're directionally going down. But to change it into trig form, you need two things. You need to find r, and you need to find theta. So r is what they call the modulus, or the absolute value of the complex number. But r is the same thing it's been in everything. It's the radius of the circle. It's the hypotenuse on that triangle. This is r, the distance from 0. That's the absolute value. So just a little terminology review here. So that's our r. Now you should know that you can always find the hypotenuse on a right triangle by doing the Pythagorean theorem, 6 root 3 squared plus 6 squared, and take the square root of that. But if you're doing this without a triangle, or without a calculator, excuse me, that probably means you're dealing with a special right triangle. So if you're in this course, you should be super familiar with your 30, 60, 90s, and 45, 45, 90s. And this angle, this reference angle between the hypotenuse and the x-axis, if it's across from 6, that's the shorter of the two legs, and this has that relationship of 6 and 6 root 3, that's a 30, 60, 90 triangle where this reference angle is 30 degrees, or pi over 6 if you're dealing in radians. So this is going to allow me to figure out two things pretty quickly. One, the hypotenuse there is always double the short leg, twice as long as the short leg. So if that side is x, this is going to be 2x. So this is going to be 12. So r is 12. And theta, at the same time of me figuring what kind of triangle this is, I'm practically there with theta as well, that's the reference angle, pi over 6 or 30 degrees. So the theta refers to this angle, the angle from standard position that would put you in that. So that would be 11 pi over 6. If you know your unit circle special, angles, the pi over 6 in quadrant 4 is 11 pi over 6. If you don't just know it off the top of your head, that would be 2 pi, a full circle worth, minus that little pi over 6. So 12 pi over 6 minus 1 pi over 6 is 11 pi over 6. Or certainly you could do it in degrees. I know this is like all these ways you could do it, but I think that's important to realize that if you get stuck one way, you can reason it out. You could do it in degrees. That would be 330 degrees, right? 360 minus that little 30 degree. And so that's 330, and then you could keep it in degrees, or if you want radians, convert to radians by multiplying by pi over 180, right? Multiply by pi over 180, and lo and behold, that will reduce right back to 11 pi over 6. So kind of nice if you just know these angles at this point in the year, but lots of ways to come up there if you're rusty with them. So now that you have r and theta, to actually write it in trig form, so you would do r, just following the format there that's above, r, which is 12, times cosine of whatever theta is, which in this case is 11 pi over 6, plus I sine of 11 pi over 6. And there is our answer. And so I told you I was going to talk two ways to do each one of these problems. That was using pretty much just a straightforward geometry approach, recognizing special rate triangles to get the hypotenuse and the reference angle. But, a lot of, textbooks, and if you go further, will, teach you to use the formulas that r is always the square root of a squared plus b squared, and that tangent of the angle you're looking for, tangent of theta, is always y over x, which you should know, or in the complex, world, y is in place of b, so, b over a, and x is standing in for a. So let's just, see how we could have arrived at these same two values. If you didn't even want to think about the triangle that exists, you just want to go right into it, and you say, hey, it's 6 root 3 and negative 6. So r is going to be the square root of 6 root 3 squared plus negative 6 squared. And hopefully you're seeing, when you square a negative, you're just going to get a positive anyway. So you can kind of ignore the negative part. But squaring 6 root 3, be careful, that's 6 squared, which is 36, times root 3 squared, which is 3. So 36 times 3 is 108, plus negative 6 squared, as we said, is positive, and 6 squared is 36. And when you add those together, you get 144. And now when you take the square root, we got a perfect square. Square root of 144 is 12. For finding the angle using the formulas, the tangent of theta is, and again, maybe you don't want to think about the triangle at all, just putting y over x, negative 6 over 6 root 3. And if you reduce this, that's negative 1 over root 3, or the more familiar, when you rationalize it, negative root 3 over 3. So now you're down to a unit circle value, and that should be a familiar equation to solve. The one thing you do have to think about is what quadrant you're in, because tangent is negative in two quadrants, right? Quadrant 2 and quadrant 4. So you at least have to think about which quadrant this would put you in if you were to graph it, so you know which angle you're going for. So the reference angle, when tangent is root 3 over 3, you should be able to come up with that pretty quickly, that's 30 degrees, or pi over 6. And in quadrant 4, the quadrant 4, pi over 6, again, we've talked, that's 11 pi over 6, or, 2 pi minus that, or all those ways we just talked about to get it degrees first, whatever. But in any event, that's how you can arrive at r and theta with formulas or with geometry. I mean, it's nice to do both ways. And here is maybe the ultimate thing to remember, is that you can check your answer very easily if you're, pretty solid with your unit circle, that here was the trig form, And you can check it by just changing it back to standard form by evaluating the trig components of that. So for example, what's the cosine of 11 pi over 6? Well, cosine of any pi over 6 is going to be root 3 over 2, and that's in quadrant 4, where cosine is positive, so positive root 3 over 2. Plus I times the sine of 11 pi over 6. Well, what's sine of 11 pi over 6? That's going to be negative in quadrant 4, and the sine of any pi over 6 is going to be 1/2. So we get negative 1/2 times that I. And when you distribute that 12, that R value, you will get 12 root 3 over 2, which is 6 root 3, and 12 times negative 1/2 is minus 6I. And so you got it right back to the standard form of 6 root 3 minus 6I. So, this is a really great way to check yourself if you're solid with your unit circle. Okay, so let's try another example here. We'll go a little bit quicker this time. So negative 8 minus 8I. I'm still going to do it from a geometry standpoint first. Negative 8 minus 8. So that's to the left 8 and down 8 if I'm plotting that. All right, okay. Negative 8, negative 8. So that's going to be to the left and down, and it's going to be the same amount since it's 8 units in each direction. There's your point. Your triangle. Certainly not drawn to scale here. That's 8 and 8. And your R is the hypotenuse. And again, from a geometry standpoint, you should probably recognize a right triangle that has congruent legs. That's an isosceles right triangle. That's a 45, 45, 90. So the hypotenuse, there's x, x, and x root 2. So that hypotenuse is going to be 8 root 2 pretty quickly. And at the same time, while thinking that, we also figured out the reference angle is 45, aka pi over 4. So the theta we're looking for, again, is, from initial position, that standard form. So theta is going to be the pi over 4 that's in quadrant 3. And if you know your unit circle, that's 5 pi over 4, one more than the denominator. Or you do pi, which is 180, right, plus that extra pi over 4. 1 plus 1/4 is 5/4. Or do it in degrees. 180 plus 45 is 225, and convert that to 5 pi over 4. So your final answer is going to be R, which is 8 root 2, times cosine of theta, pi over 4, plus I sine of 5 pi over 4. And there we go. And I know sometimes it feels unnatural to leave it like that, but that is trig form, leaving the trig expressions in it. So you're done. If you want to check, evaluate the trig expressions and distribute 8 root 2, you should get right back to where you started. Let's also talk about if you wanted to use the formulas, if you're a formula person. So R will be the square root of a squared plus b squared. So that'll be negative 8 squared plus negative 8 squared, which of course is going to make each one of those positive. So just be careful. 64 plus 64, you get root 128, which is not a perfect square, but of course what goes into root 128 is 64. So root 64 times root 2, which of course becomes 8 root 2. If you're finding the angle, you would say tangent of theta is y over x, or b over a. So negative 8 over negative 8 is positive 1. So you're saying, when is tangent positive 1? Well, there are two quadrants where tangent is positive. That's quadrant 1 or quadrant 3. And when is tangent 1? That's a reference angle of pi over 4. So that's quadrant 1 is pi over 4, and quadrant 3 is 5 pi over 4. Pi plus that pi over 4. And you just have to, again, think, I'm not in quadrant 1, I'm in quadrant 3, so I don't want that. There's my theta value, 5 pi over 4. And there we go. So 2 ways to get to those theta and R values, and a way to check yourself. Really, really solid, not too bad of a thing once you get the concept down. And lastly here, I said this is one where it's not going to be a special right triangle, not to give anything away here. But let's talk about, how to use your calculator in this kind of idea, because if it's not a unit circle, then angle, then you're not going to just know the angle by looking at it. So I'm going to approach it the same way. I'm going to approach it from a geometry standpoint first. So -8 plus 6. That's like 8 to the left and 6 up. So I'm going to be in quadrant 2, right? So 8 to the left and up 6. So definitely going to be further left than it is up. My right triangle, I went 8 to the left, I went 6 up. The two things I need to find are r, which is the hypotenuse, and theta, which is this angle right there. Just keep that in mind. Those are your two goals. Now, this is not a a unit circle triangle, so hopefully you recognize that pretty quickly. So even though I started from a geometry standpoint, I'm really relying on the formulas at this point. But hopefully those formulas make sense. They're not just pure memorization. That you're doing r is the square root of 6 squared plus 8 squared, or again, -8 squared, because that's going to give you the same value as 8 squared. So you're going to get 36 plus 64, which is 100, and the square root of 100 is 10. So your radius or your modulus or your absolute value is 10. And just for a fun fact for you geometry fans, that should make sense because 6, 8, 10 is really the 3, 4, 5 triangle, just doubled, multiplied by 2. So you might have seen that right from the start and done the problem that way and just said, hey, I don't need to do the Pythagorean theorem. It's 3, 4, the hypotenuse must be 5, but by a scale factor of 2. Anyway, so now to get this angle. Okay, so again, you can approach this purely from the formula standpoint and say tangent of theta is y over x, or b over a, 6 over -8. And you don't have to reduce it, but if you're one of those completists, you like to. So tangent of it is -3/4. At the same time, you might be a geometry person and saying, I'm just using my right triangle to find this reference angle here, theta prime, and I'm just using the opposite and adjacent on the triangle to find that. But in any event, now to find what theta is, you have to use the arctan or inverse tangent of -3/4. And that's not something you know without a calculator. So that's where we're going to bring the calculator in. And I'm going to clear this out here. I'm going to actually make sure, I'm going to do it in degrees first. Just, I feel like degrees are, a little more logical sometimes, at least initially. So if I do inverse tangent of -3/4, and I'm in degree mode, it shouldn't be a big surprise to you that your calculator is using the arctan, function. So your answer for a negative is going to be between -pi/2 and pi/2, -90 to 90. So it's going to give you about, I'll just round to the nearest tenth here, I don't know, about -36.9 degrees, which is in quadrant 4, right? That's one of the two places where tangent's negative. It's giving you this. So you, again, just have to use your head a little bit and say, I'm in quadrant 2. I should be using an angle that is more than 90, but less than 180. But all this really just did is give you the reference angle. It just gave it to you directionally, to put it in quadrant 4. So to find the angle we're really looking for, I'm just going to add 180 to it, because that's like doing 180 minus that 36.9 degrees. So theta is, and right while it's on your screen, you can add 180 to it. And that will give you about 143.1 degrees. So there's your angle. And so in trig form, you're going to say that this is r cis theta. Remember that little abbreviation can help you remember the order of things. So r times cosine of theta, which is 143.1 degrees, plus I sine of that same 143.1 degrees. And there we go. That's with it in degree form. And now we'll talk about radian form. But also good to know that, if you were purely looking at the triangle, you might have said, tangent of theta is 6/8, and just using the the positive values like a geometry standpoint where you don't think legs on a triangle can be negative, and so you'd be taking the inverse tangent of 3/4, positive 3/4. And if you do that, it's just going to give you positive 36.9, and then you end up doing the same thing. I want to do 180 minus that 36.9. So, if you were thinking along those lines, you're right there. You're doing the same thing, just know what to do with it. And then to convert to radian values, I mean, one, you can go back to your calculator and just redo the whole thing in radians. You could take your answer and multiply by pi over 180, right? That's how we convert from degrees to radians. And again, it's not going to be a nice rational value. So that's about 2.5 radians. 10 cosine of 2.5 plus I sine of 2.5. And 2.5 should, not freak you out because you're in quadrant 2, which is less than 180 degrees, so that's less than pi radians, so that's less than 3.14 radians. So 2.5 radians would seem at least plausible, at least reasonable. So there's just converting it, or if I had been in radian mode the whole time, which, really at this stage you should be comfortable with doing all those same steps. If I had done, and I can even just scroll back and grab the same expression, if I had done this but in radian mode, it's going to give you what that negative 36.9 would be in radians, negative 0.64 radians. Then if I wanted to, instead of add 180 to it, I would add pi to it because I'm subtracting from pi to get the quadrant 2 value. And there's your same 2.4, 9, 8, etc., etc. So hopefully, we tried to hit all the varieties of things you might run into in these problems: calculator, non-calculator, degrees, radians, geometry, formulas, and this makes some sense. And if you have any questions, just please let me know in the comments. But otherwise, keep working hard and hang in there, kids.